Chapter 2, Exercise 12. Verify the following identity, one of De Morgan's laws. C minus A intersect B is equal to C minus A union C minus B. All right, so it's going to be our standard set equality proof. So let's get started. Our first part is going to be us showing that C minus A intersect B is a subset of C minus A union C minus B. Okay, so suppose X is in C minus A intersect B, then this means that X is going to be in C and X is not in A intersect B. Okay, so if X is not in A intersect B, then X is not in A. Oops. X is not in B, or X is not in A, and I'm gonna write it in our language. X is not in B. Okay, there's these three cases we should consider at this point. Um, Turns out this one is just going to be like a special case of one of these two. Like either one of these implies this one, but we'll get to that. Okay, so if X is not in A, then we know that X is in C and X is not in A, which implies that X is in C minus A, which implies that X is going to be in C minus A. Oh, union C minus B. Okay, now on the other hand, if X is not in B, then X is going to be in C and X is not going to be in B, which implies that X is in C minus B, which implies that X is in C minus A union C minus B. All right, cool. And if X is not in A and X is not in B, then I'm just going to skip through it. X is in C minus A and X is in C minus B, which implies that X is in their union. Union C minus B. So, what was the original set? C minus A intersect B is indeed a subset of C minus A union C minus B. If you've done mathematical or symbolic logic before, these identities should not come as a surprise. Okay, now for the second part, you have to do the converse. So C minus A union C minus B. Okay. Is a subset of C minus A intersect B. Okay, so let's suppose X is in C minus A union C minus B. Almost forgot these parentheses. Then X is either in C minus A, I'll just leave it at this, or X is in C minus B, or both. Right, so if X is in C minus A, then X is in C, and X is not in A. So X is not in A implies that X is not in A intersect B. So I'm going to have to add an extra page. Okay, let me go back. All right. I'd rather add more lines than skip through steps. Okay, so what now? So X is in C and X is not in A intersect B, which implies that X is in C minus A intersect B. The case for B or C minus B is the exact same thing. If X is in C minus B, then X is in C and X is not in B. And then if X is not in B, then X is not in A intersect B. So X is in C and X is not in A intersect B, which implies that X is in C minus A intersect B. Cool. And yeah, so and then if X is in C minus A and X is in C minus B, then clearly it has to be included in this set by both routes. Both of them imply that it's included in the set in C minus A intersect B. So and clearly X is in C minus A intersect B. So it follows that X, that C minus A union C minus B is a subset of C minus A intersect B. All right. So we conclude that C minus A intersect B is the exact same set as C minus A union C minus B. And that's our proof. There we go. That is exercise 12. Hope this was helpful, and I will see you in the next video. Bye bye.